Hello everyone, welcome to the second workshop of the Chain Abstraction Hackathon powered by Particle Network. Today we're going to hear from Jasper on building Omnichain Oracle Feeds with Seda. I'm going to invite them onto the stage now. Hi Jasper.
Ooh.
Hello. Great, well, we can get started. And I will leave the stage to you.
Perfect. Cool. I will share my screen. I need to enable screen sharing on this browser. 1 second. Let me join from a different browser. I was trying to join from this browser that I'll be using for my demo.
Okay.
Let me join from Brave, where I have screen sharing enabled.
Okay, sure.
Be right there.
Also, everyone, you can find the recordings in the resources page in the Hacker Pack. I'm pasting it below as well, so you can find everything there, including the slides that Jasper will be going through today as well. If you haven't already, join our Discord as well. That's where most updates will go through. Let's see if this works.
Yes. Hello.
I'm back.
That'll do it.
Perfect.
We'll be building Omnichain Oracle Feeds using Seda protocol. I'm Jasper. I'm the CTO and co-founder of Seda. Yeah, let's build a price feed together. Before we kick things off, if you want to code along, please join the Hackathon questions channel on the Seda Discord. If you want to join the Seda Discord, we can do this together. You go to seda.xyz and you just click join our Discord. This will open the Seda Discord. There's probably some onboarding experience, but then you can go to Hackathon questions. After you did this, we have to make sure that you have a Kepler wallet installed in order to program along, because you need a Seda address. We'll do that together as well. So in your browser, you go to kepler.app and you click Get Kepler for Chrome. You add it to Chrome. Quite simple. And then we create a new wallet. And we create a new wallet with a new recovery phrase, which I will not share, of course. So bear with me for 1 second. All right. Just created a wallet. After you have confirmed your recovery phrase, you make sure to add Seda to your Kepler wallet. And for me, it shows up here. Let me just pin this real quick. And yeah, now we have this test account. I'll go to Seda and copy the address. And I will request some funds, which is what all of you also can do in the Seda Discord. We'll have some engineers watching, playing live faucet, and we also have a faucet that's coming live as well. Okay, so now that we have some Seda in our wallet soon, we can soon start coding. So before we start, we are going to discuss maybe I should start off with what Seda is. So Seda is programmable Oracle infrastructure, allowing anybody to query data from smart contracts. And we'll start off by going over what the lifecycle of data is. So how is it requested? Where does it go, and how does it come back? Then we'll go over how data is bridged from Seda to the destination chains. And then we'll actually start building our first Oracle feed. Cool. So let's start with the Seda data lifecycle. We have this concept of data requests, which is a transaction that you send to the Seda chain that specifies where what logic is supposed to be ran and what parameters are supposed to be entered into that logic. And this logic we call programs, which you see here. So we have programs which dictate what logic is to be executed once a data request is issued. So we have, in this case, a solver or like an user or an entity sending a data request to the Seda network. The Seda network elects a query and compute node, so like a secondary node in the network. And that node executes this Oracle program. And this Oracle program we are going to be writing today. So it's essentially a set of instructions that's ran by actors in the Seda network that specify what data is to be fetched from where. Yeah, so first it executes. So it executes the data that tells the overlay node to query, for example, a certain number of data sources. And then we go to the response. So this is sort of like a request cycle. And then we have the response lifecycle in which the data sources respond with the data. The program is still being executed. So it essentially tells you what to do with these responses. Then the overlay node and all of the other overlay nodes that are elected to report the data will report that data to Seda network. The Seda network will then execute what we call a tally program, which can be part of the same program logic. So we'll be writing that as well. And the tally is essentially an aggregation function that tells the Seda network how to aggregate the data from each and all of these overlay nodes. Then we have solvers looking at the Seda network and bridging that data back to the consumer network. Before we continue, let me make sure there's no questions. All right. Cool. So data is then bridged to the consumer network. And how this function works today, this bridging functions from solvers to the consumer network and from solvers to the Seda network are still very centralized today. So it's essentially a whitelisted Ethereum EOA that gets to publish data on the destination chain. Since our project is still on DevNet, sort of like decentralization and security takes a back foot for trying to get developers such as yourself onboarded. So we're trying to onboard as many devs as we can. And what you'll see in the future is that we're going to make some drastic changes we call batching. It's essentially how we package the data that will allow for the data to be bridged completely permissionlessly and tamper-proof. However, for today, what we're building, it will have zero effect. So everything you're learning here today will still be super, super relevant, even with the batching update, which should land in the next few weeks. But yeah, just wanted to shed some color there, some light that if you want to get your data, if you want to get access to the data on some arbitrary L2 or like a more long tail L2, now today that's not as simple to do in a permissionless manner, where over the next few weeks it will be. Cool, let's go. So we start by navigating to the link in, zoom in. Yes, sorry, Amir. I will definitely do this. Not super helpful, I think. I'll make sure for the rest of the video that this is okay. Yeah, close the chat. Seems like there is technical support in the chat. We will go to the following link. So we go to Seda protocol and we go to the encode workshop template. Make sure this is all zoomed in. And we will open our terminals and we will clone this repository. And then we will open it with our code editors. And yeah, so what we have here is the program, the Oracle program, and the meat, the logic of this program is in the assembly directory. Keep an eye on chat. Yeah, so thank you, Tiago. Yep. I'll move chat here. Move this over here. Perfect. I'll try to take it slow. And the assembly directory has this index file. And as we just discussed in the lifecycle here, we have an execution phase function and a tally function. These are part of what Seda calls an Oracle program. And the execution phase dictates how data is to be queried, and the tally function essentially dictates how data is to be aggregated. Cool, I see this bunch of errors. So what we're going to do first is bun install. We have in the encode workshop template, we have links to bun, which is, I think, the only dependency you'll need for this workshop. If you have any technical questions about the installation of that, feel free to ask them in chat. I see we have Mario in here who can help you, support you if I don't catch your question immediately. But yeah, so we have installed the dependencies, and we can run bun run test, and we see that we have a hello world template here. So essentially what we do in this Oracle program is we have an execution phase, and the execution phase simply returns a string. It says hello world. And then we have, after the execution phase, of course, we have the tally phase, and the tally phase fetches the execution phase results and just takes the first one and returns the reveal as it is a single overlay node in this case. Cool. So before we continue, we want to write, as you could already tell by the spoiler in the class naming, we want to write a price feed, and we want to write a simple price feed. So what we'll do, and I'll enter the logic in chat afterwards as well, but what we'll do is we will go to Binance and use the Binance API for this. So Binance price API public. I believe it's somewhere here. It is not. Here we go. Yes, so it's API to Binance. And then we want ticker / price. Cool. So API v3 ticker / price, and this expects a symbol like this. So I'm just going to, we already have it here. So this is an example, right? So we can have the ETH to USDC, ETH to USDT price feed, and as you can see, I just tested out here. Doesn't seem to be up. Let me try Mario's. It seems like let's try different endpoint. Sure, USDC is fine. All right. Edge case. Seems like Binance API is down. I love that. So let's try KuCoin instead. The demo gods. This is good. Should be good. However, I need to find the, let's see. There we go. So we go api.kucoin.com, and then we were here, res bot market ticker. All right. And at this point, it seems like, all right, Postman let me down. Let me see if this was a fluke with the Binance API, because that would be a little bit more easy. Yeah, all right, perfect. So this is a valid Binance API, and as you can see, it returns a symbol and a price. If we go back to our Oracle program, we can go to the execution phase, and what we want to do in the execution phase essentially is fetch the price and return it. So let's first start by storing the URL. If we We can, by the way, any suggestions for more fun feeds, very welcome to give them in chat. And then we expect a response, which is a class. So we have like a Binance response, and we can check here again. And it was indeed price is all we need. And we expect that as a string. Cool. So this is correct. Call it Binance response. The endpoint. And what we'll do next is fetch the data. So we have const response. And what we'll use is we'll use the HTTP fetch method, which is, as you can see, it's in the Seda protocol assembly script SDK, which we included into the project. Yeah, we pass in the API endpoint. Then we need to make sure that the response was successful. So what we do is we check if response is not okay, then we want to throw up an error. And for this, we use the error function on the console, custom console class, which is also in the assembly script SDK that we built, which takes a string, and we can pass that in HTTP request filled, and then we can give it some more information. This is pretty good. The status will be in bytes, I believe, so that's why I have to stringify it. Because so we use a toString on the status because it is an integer, and we use a toUTF-8 string on the bytes of the response, which is like sort of like the body of the response. Cool. So we throw the error, and then we stop the program. So I have a process.error function, and yeah, that expects some bytes, and boom, yeah, filter fetch price data. So okay, this is the edge case where the response failed for some reason. Now let's handle the success case. So what we'll do is we will parse the data into the response type. So what we do, how we do that is we have this const data, which is response. We take the bytes again, and then we JSON this in with the following attribute as a type. So this data will be in this format. So we'll basically just extract the price and put it into an object. Cool. So what we'll do now is, as you can see, the response is a string. But what if we want to return a number? And because we might want to use this in a smart contract, and smart contracts don't handle floats really well. So what we'll do instead is we will start by parsing it into a float. So we have const price as a float, and we will parse the data to make this error doesn't make a lot of sense. Let's see, I think this should just build. Then we need to make sure it was a valid number. And if it wasn't a valid number, then we'll throw another error. But actually, we can just return the data.price because it's already a string. Cool. Let's see. Yeah, then we will parse this into an integer instead of a floating point number, which will be the final result. So we have the final result. And what we'll do there is we'll take a U28, which is in the assembly library. And we will take the floating price and we will multiply it by 1 million. And this is just simply to not lose precision. So let's say we have the Doge price, for example, which might be like 0.909 or something. If we would not multiply this number first before turning it into an unsigned integer, what you would see is that this would just return 0, and that's of course not correct. Okay, and then we want to return the final result. Number from number. There we go. Now let's see if this works. So okay, yeah, Mario, thank you. I thought so as well. So since it builds, it's all good. All right, so recap. What have we done? We are fetching an API endpoint. We are handling any errors. We are parsing it into a structure that we can understand and use. We turn it into a float from a string. Then we turn that float into a integer with 6 decimals of precision. And we return that as bytes. All right. So next up is writing the logic in the tally phase that will dictate how to aggregate all of the incoming requests in the execution phase. So what we want to do here is we want to get all of the reveals. So all of the outputs of the execution phase, which we call reveals. And yeah, that's correct. So yes, what we will do then is we will have the prices, reveals as prices. As a U128 array, which we'll initialize as an empty array. Then we will loop through the reveals. And what we will do is we will reveal as price is reveals, and then we will push that. Oops. So yeah, what we're doing here essentially is parsing the reveals which come in as bytes, and we convert them to numbers. That's it. So if reveals, if there is any reveals, what we will do is let's how should we do this? So there are sort of 2 options that we can do here. There's a complex option and a very simple option. So I think the simplest option is that there's 3 options. The very simplest option is that we ignore all this and we just return the first reveal as a number. The second option is that we take the average. And the third option is that we take a median. And if you want to score points for your own project, median is the most secure algorithm for price feeds, in my opinion. But with time in mind, I am actually going to go for a bad example, which will be the average. So we'll start by getting the cumulative price, which will be here. And then what we'll do, okay, what if we do this? So yeah, I think that should work. cursor can be very cool. It can also be quite annoying here. This price. Does that work? No. Okay. Expect some sort of U128 native function, I think. Okay. So easy. Boom. So okay. We take the cumulative price where we add the reveals prices. Okay, good. And then all we need to do is, if there's any reveals, then what we will do is we will take the average. So const average is the U128 div of the cumulative price and U120 from reveals as prices dot length. Cool. All right. And what we want to do then is simply return this and make sure to import bytes from the assembly. Let me double check. Yeah, from number. Cool. All right. So we have to reveal as prices.length. If it exists, then we return the average. And if it doesn't exist, then we will throw a process.error. No reveals. Jeez. Perfect. All right. So as a reminder, we now have an execution phase. The execution phase should be executed by and to be elected or selected amount of overlay nodes. The overlay nodes execute this logic, fetching the data, performing some computation on it, and returning it. That data we then extract and parse into the tally phase, the aggregation side. We calculate a cumulative value, and we get an array which we need. Probably don't need that. This was for a median. Doesn't matter for now. Then we calculate the average, and we return the average or return an error. Quite straightforward. As a reminder, the execution phase gets executed here by the overlay nodes, and the tally phase get executed on chain by the Seda network protocol using the reports of the overlay nodes. So now we do run build, so build, and it builds into the build directory. And if we go to the encode workshop template, we can see a test should fail now because it no longer returns hello world. So I'm getting a question. The question is, Seda is going to send multiple requests to the Binance API with different nodes. What we are trying to do with the tally phase is to get the median after getting the cumulative. So we're trying to get the average in this case. Median would be better, but with ion time, I don't want to write a median helper function as we have the average is just a little bit simpler. But yeah, if you would do this yourself, yes, you want to get the median, and you are correct. So you send multiple requests to the Binance API with different nodes. The requests are sort of like in this execution phase, and in tally, indeed, you aggregate the responses of the requests. Okay, so next up, we will need to populate this N file. And there's already an RPC link in there, which is accurate and correct. It just needs a mnemonic. Aha, yes. So, okay, good point. I'm just going to get back to your question here. I don't know what to call you, so if you have the prices from Binance and CoinMarketCap, you do something different. You would do that in the single execution phase, right? So in the execution phase, you would not only query the Binance API, you would also query the CoinMarketCap API here. And then you perform some sort of median, average, whatever you can think of algorithm. I'd say that if you have like 3 to 5 feeds, any uneven number, then getting a median is probably best. If you have 2 feeds, I'd say you want to either anchor one or you want to take an average of that. But that's in the execution phase. So any of the querying is done in the execution phase. And then the aggregating of all the results from all the nodes is done in the tally phase. And I'm definitely making mental notes here that in the examples that we give, that might not be super obvious. I think maybe we want to separate concerns a little bit further and as a default have the tally and the execution phase done in different programs. But yes, I think you got it for the larger part. Okay. So like I said, we need to populate this end file and it needs a mnemonic. And this is a Seda mnemonic. So it's a Seda private key essentially, which I am not going to leak, but I'll show you where to get it. You go to your Kepler wallet and you go to your account and then you view recovery phrase. And so I'm just going to populate this env right now. And then, yeah, if you want to do this in parallel as well, it's all good. All right. I added the env file and I accidentally deleted the example. Not necessary, doesn't matter that much. Cool. So now that we have the env populated, we now have a private key. What we can do is we can deploy this binary that we wrote to the Seda network. So we will do bun run deploy. And if this is too fast, I understand this is all pretty new, can be quite complex. There will be recording posted of this workshop, so you can pause and go through all the steps again if you want to. So now this wasm hash here also needs to be populated into the env file. And since I'm not going to leak my private key still, I am going to do that on a different screen. And done. So now the exciting part. We build a price feed. We deployed the program, the logic, to the Seda network. And now we are going to trigger it. So we have this script here. It's a TypeScript script that essentially will trigger this data request that it takes from the env. And you see there's a bunch of inputs and memos, etc. We don't have to worry about that at all. This is all ready to fire. And we do that by running bun run post dr. And if we go to the DevNet Explorer Seda, okay, Explorer then, DevNet, and then we go to data request, we can see that there was just a fire data request that had no inputs, which is correct. And the result is unreadable. All right, so maybe that's something we want to change for the demo, right? So why is that? That is the case because this is like bytes of a hex string is like some interesting conversions. One way to check what the value of this actually is to go to this link. There's a type converter. And what we can do is copy this in, go to the type converter, and copy to a number, which is incorrect. Dun, dun, dun. So what happened here? We have an easy way to debug this, which is to convert this back to a string, first of all. So we'll do average U128. Let's try this out. So we have to deploy again, which will also do a build. Of course, I will have I will create a the the guy with the email address as your name, like I'm going to butcher it. I'm sorry. I will definitely do that. I will push it to a separate branch. So the main branch will be the empty project, and then I'll have like a final branch that will have the updated. That will have the updated code. So average to string, and then we return the result, and then we built this, and we have a new WASM hash. I'm not going to leak my private key. I'm not only telling you that, I'm also telling myself that. And we are back. And we will post it again and see what's happened here. It's a little Andean. Okay, JP. Mario, like giving the layup for Mario. That's amazing. So let's see. Okay, anyway, let's see what this looks like. This is ugly. Okay, there we go. Go back. I see other data requests coming in. That's good. Let's make sure that we get the right one. It starts with 9C. Okay. So now it's a string that we can read. And it's correct now. So the price of Bitcoin is 63,000. This is times a million, so that's good. So yes, it was a problem with the number conversion, as JP and Mario mentioned. So that's great. Cool. So we don't have that much time left. I would have loved to now write a Solidity contract that will allow us to actually access this data from base, which would be pretty cool. I might create a video on how to do that offline that will show how to do this. I'll do this anyway in a short, but maybe I'll create like an extended version if anybody wants to use that. What we will do now is add dynamicism to this. So let's make this a bit more interactive. Somebody in chat suggest me a price feed of an asset that is in that's available on Binance. So any asset pair or that you can think of, and we'll create a dynamic data request that fetches any pair. So what we'll do is in this postdr script, you can see that there's this input field, which takes a input. So, okay, so let's say we have DAI USDT, right? We want to be able to pass this in as an argument, which we then access here. So let's try to build this. So what we will do is just as like we have in Tally, we have the get reveals option. In the execution phase, we have the DR input option. The process get inputs, which will be bytes, of course, again. So we want to have that as UTF-8 string. And yeah, since we expect the inputs to already be in the correct format, what we'll do is we will make this a dynamic string that takes the DR inputs as an argument for the symbol. And then to be sure, we can be like to uppercase, so that it, even if we pass in lowercase, it will for sure fetch the red one. Okay. So now, if we want to run deploy, give me another, we have DAI, give me one more. So we have a WASM hash, and I'm not going to leak my private key. Data size limit is a good question. Mario, I think you have an idea there. we have some logic to trim data for large data sets of private data that will allow data providers to not make sure that they only provide sort of like relevant data. But for the size limit, I don't know off the top of my head. We have some engineers in the chat that can definitely help. Okay, so we have the new Watson hash here. And what this will allow us to do is run the PostDR script with different feeds. So we can do DAI USDT, but we can also do ETH USDT if we want for the next one. And you don't need to wait the result. So too many screens. Okay, data request. 2 that just came in, pretty snappy. And let's see, this one took us input ETH USDT, and then this one took us input, and the result is a little bit of a DAI premium. And the result here is, so the cool thing here is that we are triggering essentially decentralized oracles to fetch data from any source you want. It's completely programmable. And with the updates that are coming in, the data will be completely permissionless as well, accessible from any chain. Sorry, there's a lot of things going on at the same time, reading chat and answering questions. Yeah, so this feed that we just spun up allows you to essentially pass in any arguments for any data that's on Binance, and it will immediately become available on any network using the Seda proving and bridging system. So that is the power of what we're building here. And the cool thing is that not only, of course, do we have access to price data, but in theory, it can also be RPC data for interop solutions. It can be data pipelines for real-world asset use cases. Yeah, there's like a pretty green field of infinite possibilities that can come out of this. And yeah, so we're pretty excited about that. There could have been a whole other workshop about how we bridge that data to the chain stand and like how that's tamper-proof, etc. For that, I'd suggest you read our docs, ask questions on Discord. And as soon as we have this batching and packaging functionality live, I'm sure we will we'll be displaying that as well. Yeah, if you want to access this data from Ethereum, the feed that you just created, you can go to Seda Hardhat Starter Kit project on GitHub, which has which shows you how to sort of like configure this your project in order to query the feed that you just created. And I'll create a video in parallel tomorrow probably where I do that as well, and then I'll share it in the Encode Discord. Make sure that everybody has access to that so that you can access data on Base, Arbitrum, some more chains. Yeah, so yeah, ask any questions, deploy your own feeds. If you're building a project where you want access to your feeds on a specific network, some L2 that we don't have support for yet, please reach out on Discord. I'm sure we can make it work. And any feedback on how this all works is immensely valuable to us. Cool. Good stash and good luck. Yeah, perfect.
Great. Thank you, Jasper, for the lovely presentation. Again, all workshops are recorded and the slides are posted in the Hacker Pack. And thank you, everyone, for attending. See you at the next one.
Thank you.
Bye-bye.